So that balances the equation with a couple of 2's here. And the interesting part of this reaction is, what do you put as the phase notations? Some of it's easy. This is a soluble salt. So is this. So is this. But calcium hydroxide is only slightly soluble. And so the question is, what do you put in this space? I'll go ahead and write in the easy ones. AQ, AQ, AQ. Now, calcium hydroxide, slightly soluble. So, I'm going to draw a couple of pictures here to express the uncertainty as to what do you get with calcium hydroxide. So let's imagine here in this first beaker, we dump in some calcium hydroxide, which is solid, of course. Like you're trying to dissolve the salt. But let's say we only drop in a very small amount. Let's say 0.01 gram. So that's a tiny bit of salt. And in such a situation, it's likely to all dissolve. Slightly soluble means a small amount can dissolve. And since we only put a small amount in, it's reasonable to assume that all dissolved. And you can see I've written here the ions, that when the salt is dissolved, the bond is dissolved, so the ions are not bonded, they're separated. But we can imagine a separate situation where perhaps we drop in a lot of salt, a reasonable amount of salt. Let's say we drop in 2 grams and try to dissolve that. The salt is slightly soluble, meaning some must dissolve at equilibrium. So there'll be some ions here dissolved, but only a small amount. That's what slightly soluble means. And so the rest of the salt will remain undissolved on the bottom of the beaker as a precipitate. So this situation here has some solid and some aqueous. And that's likely to be the truth. We have no way of knowing just from these words here. We have no quantities. We don't have any numbers to work with. You cannot decide based on this information what to put in this blank. So I'm writing a nice big question mark here. It is uncertain. Will there be some aqueous? Absolutely. Defined. Yes, there must be some aqueous in either case.
Some aqueous.
But there may also be solid. There's no way of knowing. So therefore, there is no right answer to put in this space. Perhaps it will be all aqueous. Perhaps there will be some precipitate. Both are possible. So this is a limitation of the model of saying, label everything with a phase designation. There's a limit to that. Sometimes you can't get all the information you need, and therefore there is some uncertainty.
Here I'll demonstrate in real life what I've been talking about in theory. This tube on the left has 0.02 grams of calcium hydroxide. The tube on the right has 0.35 grams of calcium hydroxide, and I'll try to dissolve them both in water. I've added about 10 milliliters of water to each tube. You can see they look quite different, but I'll vortex them and we'll see how they end up. Here are the two outcomes. The one on the left, don't see any solid, completely dissolved. The one on the right, you do see a precipitate and a clear solution on top. although you cannot see any salt in this tube. I'm hoping this pH reading shows you that something is dissolved in the water. It's not just H2O. Similarly, in this clear solution atop the precipitate, the pH test tells you something's dissolved in that clear solution there. So partly dissolved, partly undissolved.